Hi everyone, today we're going to draw Lewis structures. So let's just go ahead and get right to A. Here we have 2 nitrogens and 4 hydrogens. First thing we have to do is count up the number of valence electrons. So we have 2 nitrogens, that'd be 5 each, that'd be 10, plus 4 electrons for the 4 hydrogens. So we have 14 valence electrons. First thing I do is draw the skeletal structure. There's really only one way that I can draw this, and there we go. And I have 4 electrons left, so I'm going to go ahead and put a lone pair on each one of the nitrogens. And we know that nitrogen usually forms 3 bonds and has a lone pair. So let's see if my octet is satisfied. Yes, both nitrogens have an octet of electrons. So far, this looks like a valid Lewis structure. But one more thing I want to do is check my formal charges. Let me go ahead and draw in the electrons here. You certainly don't have to do it this way, but some of you that need a little more practice determining formal charges, this works nicely. So I'll check the hydrogens. Each hydrogen has the 1 electron, and so therefore formal charges on hydrogen will be 0. And remember, if you don't do it this way, what you're doing is you're comparing the number of electrons owned by the particular atom in a bond and comparing that to the number of electrons in the neutral atom, the number of valence electrons around the neutral atom. For example, here, let's see, we have nitrogen, and here nitrogen has 5 electrons. That's good, so the formal charge is 0. And the same thing here, nitrogen has formal charge of 0. So this would be a good Lewis structure. Let's go ahead and look at B. Count up the number of electrons. We have 5 for nitrogen, 2 for the 2 hydrogens, 6 for oxygen, plus an electron for the negative charge, which gives us 14 valence electrons. So let me go ahead and draw the skeletal structure. I'm thinking it could go something like this. And I go ahead and distribute the electrons. And now, take a look at my structure here. And I see a problem with the nitrogen. Yes, both nitrogen and oxygen have an octet of electrons, but nitrogen normally forms 3 bonds, and then we'll have 1 lone pair of electrons. So this doesn't look quite right. But let's say you didn't catch that. Let's go ahead and calculate the formal charges here. So I'll just go ahead and put these electrons in. And here we go. And hydrogens look good. I have a formal charge of 0. The oxygen, that has a formal charge of 0. It has the 6 electrons. And the nitrogen, look at this. The nitrogen has 6 electrons. So that means there would be a -1 formal charge for the nitrogen. And that's good because our formal charges should add up to the charge that is on the ion. And so that works. Now, a problem, if you look a little closer, notice that the nitrogen is less electronegative than the oxygen. So really, the more electronegative atom should have the negative formal charge. And so that indicates our structure is not a valid one here. So let's go ahead and redraw this. This time I'm going to put the hydrogens on the nitrogen. And here we have our oxygen. So let me go ahead and distribute these electrons. And I'll put a lone pair here. And so we have our nitrogen and oxygen. We both have an octet of electrons. That's good. Now, let's go ahead and check the formal charge on this one. Okay, so again, the hydrogens have a formal charge of 0. This is good. The nitrogen in this case has 5 electrons, so its formal charge is 0. And the oxygen has 7 electrons, so it has a formal charge of a -1. So this would be the valid Lewis structure.